Physics Calculus, Topic 4.3, Number 5. The cost of manufacturing X cell phones is C equals 10,000 plus 20X plus X squared over 10,000. We want to find the rate of the average cost to make 500 cell phones at the rate of about 100 units per day. Now, since we're being asked for average cost and then the rate of the average cost function is created by taking the cost function and then dividing it by x. Once we do that, we're going to find the rate, which means we're going to find a derivative of that. So let's find the cost function, which is 10,000 plus 20x plus x squared all over 10,000. We're going to divide all that by x. Okay, so 10,000 over x is the same thing as 10,000 x to the negative 1 power. 20x divided by x will be 20. And x squared divided by x will be just x. So that'll be plus x over 10,000. Okay, so now we have the average cost function right here. Now the rate of that, which changes, we're going to take a derivative of this. Now the rate will be a rate that is per day. So it'll be a function with respect to t rather than x. And so since we're taking a derivative with respect to t and not x, that means that the x itself and the c will now be functions. And a derivative of a function, you must use a chain rule for that. So let's take this here, the average cost function equals 10,000 x to the negative 1 power plus 20 plus x all over 10,000. And we're going to take a derivative of all this with respect to time. Okay, so the derivative of the cost function will be 1, then times the chain rule, which is the average cost function, should I say, all over per time. The derivative of this will be negative 10,000 x to the negative 2 power, then times chain rule, which will be dx over dt. Okay. The derivative of a constant is 0, so that doesn't change. And the derivative of x is 1, so this will be 1 over 10,000. And then times chain rule, which is dx all over dt. Alright, we have our formula now. I'm going to clean this up just a little bit, okay, with the x to the negative 2nd power. So we'll say c, average change function per time. It really should be a d next to that. Okay, sorry. Really should be a d next to that c there. And I'm going to make this into negative 10,000 all over x squared, and dx, dt is here, and this will be plus 1 over 10,000 dx over dt. Alright, now we're again after the rate of the average cost, which will be this function right here, and we want to know when we as we make 500 cell phones. So the x will be 500. So 500 squared. Now dx per dt, since x stands for the cell phones, and this is a change of cell phones per time, which is cell phones units basically. So they're changing at 100 per day. So this is 100 per day plus this is 10,000 in the denominator, and this again will be 100. So we'll put a 100 there. Sorry. We'll put a 100 here for the dt, dx over dt right there. And let's begin to simplify this. Let's see. The 500 will have 5 times 5 is 25, and then 4 zeros. Here we have 6 4 zeros plus 2 zeros, which is 6 zeros. 1, 2, 3, 4, 5, 6. And here we have 2 zeros on top, 2 on the bottom. They'll reduce down to 1 over 100, just 2 zeros there. Alright, so 4 of these zeros and 4 of those zeros will go. We end up with a negative 100 over 25, which is negative 4. And then plus 1 over 100. Okay, so this is just about a penny. 1 out of 100 is a penny. This is negative $4, so that'll give us negative $3.99. And that's how many dollars per time, which is in days. So that's our change in the average cost function per change in time.